lesson, I'm going to take you through our science and technology grade 6 lesson, which will be on composition of air. My name is teacher Felix Nakitare from Trans County, that is Maridadi Comprehensive School. Now, in today's topic, composition of air, we shall be looking at the components of air and their uses. Components of air and their uses. Now, as we start our lesson today, I want us to look at our expectations, or rather the outcomes. What are the learning outcomes of our today's lesson, which is composition of air as the strand and the substrand components of air and their uses. The first expectation in our today's lesson is that the learner should be able to define what composition or what components means. We should be able to define the term composition or components so that we understand what components of air means. Number 2, we should be able to list all the components of air and their uses. We should be able to list all the components of air and their uses. Now, welcome, putting into consideration our learning outcome or objective of the lesson. As we go together all the way till the end, be my guest today, my viewer and my listener. Now, I want to start by defining what we mean by components or composition. Components or composition of air. Components, the word components or composition, it means the things or the items that make up something. That is the components or the composition. The things or the items that make up something. So if I talk about components of air or composition of air, it means these are the things or the items that make up air. I can give an example. Somebody can ask you, what are the components of tea? What are the components of tea? That means what makes up tea. If you put your tea, if you display tea, there are some items or the things that have been used so that the final product is called tea. In the components that make up tea, we have tea leaves, water, and probably sugar. For some people, they can add milk. So you can have a cup of coffee or a cup of tea. The components are the things or the items that have been used to make that tea. I've said the components there will mean you use water, you use sugar, and you use tea leaves or cocoa or coffee. Those are the components, the things, the items that make up tea. Now, under components of air, as I've said earlier, it means the things or the items that make up air. What are these that we refer to as components or composition of air? We have the 4 main ones, the components of air, the things that make up air. The first one, is oxygen. That is the first component of air. Then after oxygen, we have the second one, as you can see. As you can see on your screen, the second one is carbon dioxide. Then number 3, apart from carbon dioxide, we have nitrogen. Then number 4, we have rare gases. Those are the 4 main components that make up air, and then you have 2 extra. Apart from these 4 main ones, we have 2 extra. We have water vapor. It also makes part of the air, water vapor, and some dust particles. All those make up air. So these are the first 4: oxygen gas, carbon dioxide gas, nitrogen gas, and rare, also called noble or inert gases. These 4 are the main components of air. And as I've said, there are 2 more, although they are not major ones, but they are also part of the air, especially when the air is not purified. So when the air is pure, we have oxygen gas, we have carbon dioxide gas, we have nitrogen gas, and finally rare or noble or inert gases. And as you can see here, the first one is referred to as gas, oxygen gas, carbon dioxide gas, nitrogen gas, but in the last one it is written rare gases or noble gases. Alternatively, it is also called inert gases. Why is it called gases? It is called gases because there are several gases here. The first one is called argon. Then we have another one in the group of rare gases. It is called neon. And then lastly, we have helium. These 3, argon, neon, and helium, they make what is called rare gases or noble gases, or also inert gases. They are 3, that is why they are called gases. And they are rare because they are not easily found. Therefore, as we come to this level, we now know if we are asked to name major components of air or the composition of air, we have the oxygen gas, we have the carbon dioxide gas, the nitrogen gas, then the rare, noble, or inert gases. And if we are asked to give an example of rare gases, then I've given you 3 examples. We have the argon, we have the neon, and the helium gas. Having gotten the components of air, having known them, the major one and 2 minor ones, which I've said are water vapor, because water vapor is found in air, in the atmosphere, and also dust particles. You are now able to name all the 4 major and 2 minor components of air. We then move straight to their uses. Knowing all these components, each of them has its use. How do we use all these? What is the use of oxygen gas? What is the use of carbon dioxide gas? Then number 3, we shall be looking at what is the use of nitrogen gas. And finally, if we are asked, what is the use of rare, noble, or inert gases? We therefore straight away go to the first one, which is the oxygen gas. We want to look, where do we use oxygen. For what purpose? The first one, the first use of oxygen. We use oxygen during breathing. Like the way I'm talking, without oxygen, I'm not able to breathe. So we breathe in oxygen, and that oxygen is used in our bodies. So the first use of oxygen, it is that oxygen is used in breathing, and it is used in different ways. As you can see in your screen, the first one, that first diagram shows a patient in hospital. You can fall sick, you are taken to the hospital, and while at the hospital something happens, maybe due to infection or any other effect, like maybe you are involved in an accident where maybe your lungs or your nose gets some problems and you are not able to breathe properly. You will be given oxygen. There are some machines that are used in hospital to enable you to breathe. So the first diagram there shows a patient admitted in the hospital, and this patient is put on oxygen. Therefore, the patient uses oxygen during breathing. The second one, we have that person is inside water body. This person is called a sea diver. The people who go to dive in the oceans or in the seas or in the lakes, they go deep into the waters where they are not able to breathe normally as we breathe outside water in the normal environment. So sea divers carry some containers, special containers, as they go to work or to do any experiment or anything under or in deep waters. And that one gives us part of this first use. That's the second part of the first use of oxygen, that is in breathing. So the first diagram shows a patient in hospital using oxygen during breathing. Then the second diagram shows a sea diver using oxygen while diving in the sea, in the ocean, or in the lake. Then the third diagram shows a person in the normal environment where most probably where I am now and where you are now, we are breathing in oxygen. Then we breathe out another type of air. So that shows us that the first use of oxygen, as we have seen, is that oxygen is used in breathing. The second use of oxygen, apart from breathing, the second use of oxygen is that it is used in burning or combustion. We may take it for guarantee when we light fires at our home, when we use a stove, when we use a cooker, when we use a candle, when we use a lamp. It is not obvious that that lamp that you are using or candle must automatically light, or that stove or gas cooker you are using. If oxygen lacks where you are, then that candle will not light. Therefore, that brings us to the second use, where we use oxygen during combustion or burning. In that diagram, the first one that you see, we shall have that experiment later in the other lesson, but now just to explain, we can see we have something like a trough or a basin. We have a glass, and inside that glass, we have a candle. That candle has been lit. It is lighting. It has some flames or some fire. And that candle lights or burns because inside that glass there is some oxygen. There is a lot of air, yes, all the components that we have seen, oxygen, carbon dioxide, nitrogen, and rare gases, all of them are found inside that glass. Now, when you light the glass, when you light the candle and cover it with the glass, the candle will burn. It will continue burning for some time, depending on the amount of oxygen inside that glass. And when the candle burns, after some time, maybe 5 minutes, maybe 10 minutes, maybe 3 minutes, depending on the size of the glass that holds a certain amount of oxygen, that candle will later go off. Why will it go off? It will go off because the oxygen inside that glass will have been used. And the rest of the components of air remaining, that is carbon dioxide, rare gases, and nitrogen, do not support burning. Once oxygen is used up, the candle will go off. So that shows that oxygen is used in burning or combustion. Later, we shall do that practically. The third use of oxygen is that oxygen is used during germination. And in germination, it simply means, what do we usually do when we go out in the farm? We take our seeds, we go and we put our seeds in the soil. We say we've gone to plant or to sow our seeds. When sowing or planting seeds, there are 3 things that will facilitate our seed to germinate, then to grow. What are these? For a seed to germinate, then grows, it needs to have some amount of warmth or hotness. It also needs some water or moisture. And finally, it needs oxygen. And in our part today, we are looking at oxygen. So those 3 conditions are necessary for a seed to germinate. But the one that we are looking at is that a seed needs oxygen to germinate. Without oxygen, a seed cannot germinate. And is it a must for a seed to be placed inside soil for it to germinate? No. I've just briefly said that under the conditions necessary for germination, a seed needs warmth, moisture or water, and oxygen. So having those 3 conditions, even if, like on this my table, if I put here a seed or some seeds, and I provide some moisture and warmth and oxygen, this seed will germinate. After germinating, it will develop some shoot and some roots, and it will start growing into a plant. Therefore, oxygen is used in seed germination. Having reached there, we now get that the 3 uses of oxygen are, number 1, we use oxygen during breathing. Number 2, oxygen is used during combustion or burning of items. And number 3, oxygen is used during germination of seeds, where seeds grow and develop into plants. Those are the 3 uses of oxygen gas. So if you are asked, then you can get that oxygen is used in those 3 ways. We come to the second one. We are finished with oxygen. We have given the 3 uses. Then we come to the second one, is carbon dioxide gas. Where do we use carbon dioxide gas? And by the way, where do we get an example of carbon dioxide gas? Somebody may wonder, where is this gas, carbon dioxide? I can give a very simple example of carbon dioxide gas. When we take in oxygen as animals or human beings, oxygen is used in our body. And after being used, it comes out of our body as carbon dioxide. Just imagine the type of air that comes out of our body. When you breathe out, if somebody breathes out near you, is that air that a person breathes out appealing or not appealing? Is it pleasant to your nose? When you pollute, we say a person pollutes the environment. That air that is produced by this person is an example of carbon dioxide. Now let's look at how useful is this carbon dioxide. I'll just give an example. How useful or what is the use of carbon dioxide? Number one, the first use, note that carbon dioxide is used during the process of photosynthesis. Carbon dioxide is used during the process of photosynthesis. And what is photosynthesis? Photosynthesis is the process where green plants make or manufacture their own food. The process where green plants, and green plants, these are plants which have green leaves. We have others like mushroom. They do not have green plants, so they are not green plants. They are called non-green plants. Therefore, green plants manufacture or make their own foods through a process called photosynthesis. And just briefly to mention, how is this food manufactured, or what helps the food to be manufactured? I've said green plants because these green plants contain something called chlorophyll in their leaves. And the use of this chlorophyll in their leaves are put together with water in the presence of sunlight and carbon dioxide. The leaf is able to scientifically manufacture its food. As we can see on our screen in that diagram, we have an example of green plants, and you can see sunlight from the sun. There we have sunlight directing its rays towards the leaves of that plant or that tree. The tree is green, meaning it contains chlorophyll. That tree must have some water. And now together with the carbon dioxide, the tree is able to manufacture its own food. And the food will help that tree to grow. Just as we human beings and animals, we eat food so that we grow and we become well. We also become healthy. Therefore, the first use of carbon dioxide is that it is used during photosynthesis. That's the first use of carbon dioxide. The second use of carbon dioxide is that carbon dioxide is used to preserve food. Carbon dioxide is used to preserve food. Or an example, where is carbon dioxide used to preserve food? In the soda and other soft drinks that we take, and most commonly soda. Soda is preserved, it can stay for a long time. It can even be preserved so as to stay for 3 months, for 6 months, because inside that soda there is a preservative, there is a chemical that has been put so that the soda does not go bad easily. That preservative that has been put in soda is called carbon dioxide. And if you want to be a scientist, you want to try and see, truly, is there carbon dioxide in soda? The best example, use a type of soda called Coke. And you can use it in 2 ways. You want to see if true there is carbon dioxide in that soda or no. Take a bottle of soda and shake it violently. Take a bottle of soda, it contains a soda, and mostly Coke. It has a lot of carbon dioxide in it. If you shake that bottle of soda and you leave it, the carbon dioxide in the soda can break that bottle. And if it does not break the bottle, after shaking, immediately open that soda. Nearly the whole amount of soda or the whole amount of soda will get poured out of the bottle. Or alternatively, you can also open that soda without shaking it. Open it first, remove the lid. Then while covering the top part of the bottle with your hand, try and lightly shake that bottle. After removing your hand or your finger that you had used to cover that bottle, you will see that the soda will come out of the bottle. It will pour out. Why? Because the carbon dioxide will expand and it will force that soda to pour out. Also, while drinking that soda, take that soda and drink it quickly. After drinking it quickly, you will find that there will be a lot of gas in your stomach. I think that's the best example that you can use. Just take, I think, Coke or Crest or Sprite. Take it quickly, not little bit by little bit. If you take it quickly, a short time after taking that soda, you'll find that you will have a lot of gases in your stomach and you will be forced to produce or to let out that carbon dioxide. So carbon dioxide is used in preserving soft drinks like soda, like energy drinks, among others. That's the second use of our carbon dioxide. Use number 3. Carbon dioxide is used in extinguishing the fire or putting out the fire. When you see maybe a house burning, maybe an item is burning, maybe a vehicle is on fire burning, there's an abrupt fire outbreak, then you see firefighters, they come there with firefighter vehicles or firefighter items or containers. In that container that they use, or in that firefighter vehicle that they use, they come with gadgets, and these gadgets or items, as you can see on our diagram, that is a firefighter. So this container that this firefighter has, you can see there is a pipe, and that pipe directs some items towards the base of the fire. That is the source of the fire, where the fire originates from. You direct it there. What is that whitish substance that you see? That is chemical substance that is made up of carbon dioxide. And this chemical substance, when it is sprayed at the base or the source or the start of fire, because carbon dioxide does not support burning, it will put out that fire. And that leads us to the third use of carbon dioxide, that carbon dioxide is used to put out fire, or it is used in fire extinguishers to put out or to extinguish fire. Remember number 1, we said carbon dioxide is used in photosynthesis, that is process where plants make their food. Number 2, we have seen that carbon dioxide is used to preserve food and particularly soft drinks like soda. Then number 3, we have seen that carbon dioxide is used in fire extinguishing, that is to put out fire. Those are the 3 uses of carbon dioxide. In case you're asked, we've looked at the 3 uses of oxygen, the 3 uses of carbon dioxide. And now we move to our gas number 3. That is nitrogen gas. What is the use of nitrogen gas? What is the use of nitrogen gas? The first use, nitrogen gas is used also, just like carbon dioxide, it is used in preservation of food. When foods are packaged or stored in some packets, nitrogen is also used in those packages to help preserve the food so that the food does not go bad. So the first use of nitrogen is that nitrogen is used in food preservation. It is put in the containers or storage containers that food has been packed, and that food cannot go bad. So that's the first use of nitrogen in food preservation. Then use number 2 of the same nitrogen. Nitrogen is also used by plants. And how is it used by plants? We've said in carbon dioxide is used by plants to manufacture their own food. Carbon dioxide is used by plants to manufacture their own foods. What about nitrogen? What is the use of nitrogen in plants? Nitrogen is used by plants to get nutrients, and these nutrients are used by plants to make proteins. And now, which plants are these that use nitrogen? The plants that use nitrogen are plants which are referred to as legumes or leguminous plants. An example of leguminous plants are beans. We have a bean plant. We have peas or cowpeas. And we also have groundnuts. These leguminous plants are plants that have some things called nodules. We can see on our screen we have there a bean plant, an example of bean plant. And I've said that bean plant is an example of a legume or leguminous plant, and they contain nodules. In these nodules is where nitrogen is scientifically or chemically broken down into nitrates. So nitrogen is broken down by legumes into nitrates, and then these nitrates, the nutrients of nitrates, are used by plants to make protein. Somebody can ask you, which plants give us protein? Apart from the protein that we get from meat or from eggs, we have plants that give us protein. I've said earlier, we have an example of bean, cowpeas, peas, and groundnuts. These are plants that contain nodules, and they use nitrogen to make proteins. So when we eat such plants, we get proteins. That one has been the second use of nitrogen by plants. Use number 3. Use number 3 of nitrogen. Nitrogen is also used to make fertilizers. Nitrogen is used to make fertilizers, and that is why we learn about different types of fertilizers, and we have an example called nitrogenous fertilizers. These are fertilizers that contains nutrients like nitrogen. And now plants, I've said plants like beans, they have the ability to get nitrogen from the air. But we have other plants that needs those nutrients gotten from nitrogen, and these nutrients are called nitrates. These plants, like maize, that do not have nodules, cannot get nitrates directly from nitrogen. Therefore, we use fertilizer that contains nitrates. And these nitrates are got from nitrogenous fertilizer. This fertilizer that has been made with nutrients or chemicals from nitrogen. Therefore, nitrogen is also used to make fertilizers called nitrogenous fertilizers. And these fertilizers help the plants to grow well. They help the plants to grow well, and after growing well, they provide proteins. Therefore, nitrogen is used to make fertilizers. The next use of nitrogen. The next use of nitrogen is that nitrogen is used in bulbs and fluorescent tubes. For a fluorescent tube or for a bulb to light, there is some air inside, and this air in the fluorescent tube is not carbon dioxide. This air in the fluorescent tube or bulb is not oxygen, it is nitrogen. And we can see on our screen, we have that is an example of a bulb. Nitrogen is put inside that bulb. And what is the work of that nitrogen in the bulb? Inside the bulb, we have small wires. These are the wires that glow to produce light. And these small wires are called filament. Now, when a bulb lights or a tube lights, it becomes hot. And when it becomes hot, it can burn. Now, what prevents that small wire called filament inside a bulb from burning out? It is that air inside the bulb called nitrogen that prevents that filament from burning. Yeah, so that's the fourth use of nitrogen. It prevents that air inside the bulb, that filament inside the bulb from burning. We've seen now that our nitrogen has around 4 uses. We quickly go through them. Number one, we've said nitrogen gas, just like carbon dioxide, is used to preserve food. Number two, nitrogen is also used by plants. And these plants that use nitrogen directly are called legumes or leguminous plants. The plants use nitrogen so as to be able to make proteins. Then use number three, nitrogen is used in bulbs or fluorescent tubes. And here, the nitrogen gas prevents that small wire or the filament from burning out. That is the importance of nitrogen gas. After that, we move to the fourth one, the fourth type of gas, which is called rare gases, noble gases, or inert gases. And I say they are called gases because they are three. At our level, we have these three examples. We have the argon, we have the neon, and we have the helium. These three gases are what are called rare gases, noble gases, or inert gases. Now let's look at the use or the function of these rare gases. What is the function of these rare, noble, or inert gases? The first function or the first use. These noble gases, they are the gases that burn inside a bulb. Remember I've said nitrogen gas is also found inside a bulb. And the work of nitrogen gas is to prevent the filament from burning. But argon gas, an example of a noble or rare or inert gas, is the one that now burns inside the bulb. It burns to produce that light and that heat. Therefore, the first use of the rare gas or noble gas is to burn and produce light inside a bulb or a fluorescent tube. Take note of that. Don't confuse the use of nitrogen gas in a bulb and noble gas in a bulb. Nitrogen prevents the filament from burning out, while the noble or rare gas inside a bulb is the one that now burns so as to produce that light. So the first use of noble gas is that it is used in bulbs and fluorescent tube to produce light. The second use of noble gas, apart from burning to produce light, the second use of noble gas is that this noble gas is used in decoration or also advertisement. You can go in a shop, we can see in our shop decorations made, maybe like a shop written M-Pesa, or maybe a boutique, something like that. The words are written not by ink or by paint, but they are, I can say, they use like electricity. They glitter. There are some lights, but the lights produce the picture of things or the words. You can see like in some shops it is written M-Pesa and it is lights that glow showing the word M-Pesa. Maybe lights that have been used to show that maybe that's a shop for selling phones. That display or decoration is an example of a decoration or advertisement using the noble gas. So noble gases are used in decoration or in advertisement. That is the second one, and I've given an example. You see in shops written or maybe decorated. You can see also in our vehicles, you can see a bus or other vehicles, they are decorated. You can see a wire going around maybe the front screen of the vehicle, and it has some lights running all through. That is a decoration, and the air used in that decoration is an example of a rare gas. And most likely the one commonly used is the helium. Therefore, noble or rare gases or inert gases are used in decoration and advertisement. Also, apart from decoration, the same rare gases are used in balloons. And the commonly used example in balloons, they put in different balloons, like we can see one there. The best example is the helium, because helium is light. It will not make the balloon to be heavy. So helium, as an example of a rare or noble gas, is used in our balloons. Also for decoration. You want maybe balloons of different colors, you want to fix them somewhere. You put noble gases in the balloons of different colors, and you put them for decoration, like when you go to attend weddings or to prepare weddings, instead of physically inflating the balloons using maybe children or you yourself, we can use noble gas to inflate the balloons so that they are used in our decoration. And you can also see there an example of advertisement or decoration. That word open, that is a surface. We use those decorations using noble gas to show the word open and that circular part. So that brings us to the other use of our noble gas. The last use or function of our noble gas is that the noble gas is used by people in workshops. You can try to figure out where is it used in our industries, in our workshop. Is it used in lighting? Because in our industries, in our workshops, in our factories, we have bulbs, and these bulbs use lights. The lights uses air. We've said the air that is used. We have people using metallic items. Maybe people who want maybe to fix some metallic items, making maybe metallic tables, metallic seats, metallic chairs. They use a machine called a welding machine to cut metals, to melt metals, to bend metals. Metals are hard. You cannot easily bend them. For you to bend, to change the shape of a metal, you need to melt that metal. For you to cut metal into some pieces, or for you to make joints, to connect joints of metals, like maybe we can take an example of a joint. You are making a table, a metallic table, or a metallic chair, a metallic stand. You want to join different pieces of metallic materials or metals. You will use a welding machine to melt those pieces of metals so as to join them. Now, which gas is used in welding machines? It is not oxygen, neither is it carbon dioxide nor nitrogen. As we can see in our diagram, there we have a welding machine and a welder trying to melt some metals so as to make maybe a metallic bed or a stand or something of the sort. Therefore, that shows us that there is a gas that has been used there to melt those metals, and that gas is definitely a noble gas, which is either argon, neon, or helium. So that is a noble, rare, or inert gas that has been used. And with that, we quickly look at what I've looked at as the uses of rare gases. The last one that we have just finished dealing with is that these noble gases are used by welders in welding machines to melt and use metallic materials. So noble gases are used during welding. Number two, we've seen that noble gases are used in burning in the bulbs. For a bulb to light, then rare gas, particularly, in fact all of them, neon, argon, and helium, are used. And when they burn, the bulb and a fluorescent tube are able to produce light. Number three, noble gas is used in decoration, and the same decoration can also be termed as advertisement. You advertise. As you decorate, you write the name of the product that you want to display, and that one is decoration or display using our noble gas. Therefore, having known all that, coming to the conclusion, I want us to look at the quantity of these gas or gases. Each of them, are they of similar amount in the atmosphere? We have all the four of them, the major components. Are they in equal amounts in the atmosphere, or are there other components that take more prevalence, or they are more in quantity than the others? We shall look at them just right now, and we know. Oxygen is made up of approximately 21% of all the components of air. Then we come to carbon dioxide. Carbon dioxide is made up of 0.03%. And when we talk about percent, when we add, finally, we shall come to 100% composition of air. Nitrogen is the third one. Nitrogen is the third one and is made up of approximately 78%. Then finally we have the rare, the noble, or the inert gases. And these rare gases or noble gases or inert is made up of 0.97%. So this is how these different components of air are distributed in the atmosphere. Oxygen, 21%. Carbon dioxide, 0.03%. Nitrogen, which takes the greatest percentage, is 78%. And finally, the rare gases or the noble gases makes up 0.97%. When you add, you get that it comes up to 100%. So, in case you're asked which component takes the biggest percentage or share of components of air, then nitrogen takes the biggest share, followed by oxygen, which is 21%, takes the second share. Number 3, we have the noble gases that take up approximately 0.9%. And finally, the one that takes the least share in the components of air is the carbon dioxide that takes 0.03%. You can be asked to present it in a pie chart. You get that one. And now, with that, having seen the definition of components of air and the components themselves here and their uses, you should be able to explain whenever you are asked. And that brings us today to the end of our lesson, where we have looked at the definition, the components, and their users. Thank you very much today for being my viewer or my listener. Until next time, when we meet in the same science lesson, I'm yours, Teacher Felix Nakitare. I want to wish you a blessed day and continue watching. Thank you very much.